So your ore is composed of some combination of iron oxide and silica, bits of sand. See the
Okay.
shiny
I
stuff
do,
in there? The iron oxide can take a number of different forms. That heavy yellow rock that I have inside, I think it's in the form of some sort of hydroxide. Uh, the red stuff here is hematite.
Okay.
That's like regular red rust. And the black stuff that is magnetic is magnetite. The red stuff is not magnetic.
Oh, yeah.
But yeah, this stuff, that's not magnetic. That is.
Huh.
You get the conversion to both the hematite and the magnetite by roasting the ore. Basically, put it in a fire till it glows
So it didn't come out of the ground like this. You roasted
No,
this
it
already.
comes
Okay.
out like that yellow rock.
Oh,
If
got it. Okay.
I'll grab it again in a minute.
Okay.
But first you roast it. It does two things. It goes through a conversion, drives off the excess water. It also makes it much, much easier to crush.
Okay.
Yeah, very, very easy to crush, which is we want because you need to get it all into like little pea-sized pieces.
Okay.
So then you have a large stack, basically a big clay tube,
Okay.
and that's kind of like a much larger version of the steel making
Yep.
thing we were doing. And you'll have that full of charcoal, have to be chopped up to the right size, kind of like what I have over there, and get that burning. You start putting in a measured charge of more charcoal and more ore. Just
In layers, kind of?
kind of put them in together. It's usually written up in books as layers, like in description, but I believe you just you can have them mixed together. It doesn't need to be in a layer necessarily. I need to look into that detail more. I'm definitely not an expert on this.
But you made it happen.
I just had a lot of beginner's luck on this one, I think.
Okay.
So you have a really, really hot fire, lots of free carbon in there, and the energy from that fire and the existence of that free carbon, the bond between the oxygen and the iron is able to be broken, and that oxygen then immediately combines with carbon dioxide, and it floats off. The iron will condense into little globules and get mixed up with all of that molten silica, the sand there.
Right.
Which is
Probably
what
the sparkle,
ultimately
right?
gives you this.
Okay.
Now, how much carbon the iron absorbs during this process will also affect things like, does it turn to cast iron, which we don't want because it's not forgeable. Too much carbon will get you a liquid iron, and yeah, that won't be forgeable. But just the right amount. This is a matter of temperature, and the slag composition apparently has a big effect on things like what the slag is made of.
Okay.
I'm going off just repeating what I've read there. I don't have experience with knowing all the details. Oh yeah, that's really magnetic. Because that's where the iron really is. And that's really the process there. You're breaking that bond between the iron and oxygen with enough energy and something else for that oxygen to bind to.
Okay. And then you're left with bloom.
Yeah. And you pull this out of the furnace ideally while it's at a bright white heat, and we would first hammer it with on a stump. That will, it's a larger surface for one, and it keeps things from going all over the place, and it'll burn kind of a little depression, which will help kind of compact it instead of just flattening it and pieces scatter, if that makes sense. Once you've got a fairly solid mass, then you can start hammering on the anvil
Okay.
and forge it out into something that stays together, hopefully.
And as you're forging, all of the slag and stuff is popping off.
A lot of the slag is getting forced out. It's like acting like flux when we use it
Right, okay.
in forge welding. Some small amounts get trapped inside, and I've shown you the kind of grainy
Wrought
structure
iron.
of wrought
Yeah,
iron.
yeah.
That's where that silica basically originates from. It's from that smelting process.
Huh. Okay.
And you would fold it, you fold it kind of like mixing bread dough a few times. It will give you a more homogeneous product because one part might be a little bit of cast iron or very high carbon. This other spot has very little, so it's very inconsistent in character when you first take it out.
Okay.
So that's more or less the process there.
Okay. And you said earlier this amount that you ended up with came from a piece of bloom about that big?
It came from a piece I broke off that was maybe about that big.
After folding it several times and all that.
Or a little clump like
I
this.
see.
And if you look real close at that, you can see there's inclusions, there's air voids and pockets, there's some slag mixed in there. I'm just kind of going out roughly visually. This is about the size of the little chunk of this that I broke off.
Got it. Okay.
And where did I do it? Little. Oh, you got it. So you'll wind up with something definitely smaller visually in this bar at the end because you're getting rid of the slag, and some of the you're going to lose lots of scale too, and things that were not forgeable, but the cast iron will break off as well. So
And you're doing all this hot each time you're.
Oh yeah, this you want to do this up at a forge welding
Right,
temperature,
okay.
and ideally you can get the first part of that done just with the heat straight from the bloomery.
Bloomery. Wow.
Everything I've read suggests that your best time to do that initial compacting is from the bloomery because it's really hard to get the right heat and environment by reheating it in a forge later.
I see.
But I don't have practical experience behind all of that yet.
Yeah, but this is amazing that you did the whole process like that. Yeah.
I will say again, this was a fair amount of beginner's luck in here. But I was excited to notice that it did actually work.
Yeah, pure
And I
Arkansas
know for
steel.
certain now that this ore is a viable ore.
Yeah.
Because that was in question before. It was kind of right at the lower limit of how much iron needed to be in the ore. Elemental iron content needs to be at least 50%.
Okay.
If you go lower than that, you're more likely to just wind up with slag.
Okay.
The iron is dissolved in that silica. That's what's making it that black color.
Okay.
And if there's too much silica and not enough iron, there won't be any metallic iron that kind of collects onto itself there.
Okay.
There has to be like a certain critical quantity.
And is this the only way to test it, or are you weighing it, or
there's other ways,
magnets and
there's
stuff?
other things to test it. Like this will tell you if the ore works.
Okay.
You can also, were you here when I tried those little dumplings, like little clay containers filled with a little mix of ore and charcoal?
Huh.
I couldn't get those to work reliably, but that's a way of testing it. Take some powdered ore and take some charcoal, put it in a sealed container like a crucible, heat it up really hot in the forge, and you should be able to use that. Like if you get a little iron bead, you'll know it works.
Okay.
I had trouble getting that hot enough consistently to work.
Did
I just decided to jump into it because I had the charcoal made and I had the ore crushed up. Let's
Okay.
just see what happens.
Did you were you just like hiking around and saw that rock looks like ore, or like how did you?
It was one thing that can tell you about ore is, let me go grab that rock.
Okay.